So we've had these welcomes, and I would start by saying I'm so honored to be invited to do the keynote, and thank you so much to the local organizing committee for all the tremendous work you have put in. Even though we have had these formal welcomes, I wanted to add a small one of my own. But it gives a chance to show one of the things I have been using most out of Csound, which is Rory Walsh's Cabbage, and here represented by Ian McCurdy's HardSync synthesizer. And the translation from my voice to MIDI notes to be played on this synth was done by another Cabbage plugin, much uglier, that I wrote to do this this conversion. So yeah, I would like to take this chance to not because of talking about all my projects, but talking about the great flexibility and the abilities of the Csound language and of the abilities of our community to assist. A lot of these projects concerns real-time and low latency playing to be able to respond in a live environment, but there's a lot of audio programming tools out there that cannot do offline processing. And for all of the years I have been working with Csound, I've been trying to get away from that. I was very excited when we could start doing that, but there are still a few things that is excellently done. And we need this offline processing support. I'll get back to this. So, and my feeling is that all I know about audio processing and programming, I've learned from you guys. So this is my thanks for that. Remember this? Gabriel Maldonado in the late 90s made this real-time Csound, DirectX Csound AV. And this was my first venture into using Csound. And I must admit, when I got to know the language, I had no idea what it was, how to use it. I had a hunch that I needed this. So I started reading the reference manual. That was, and there was no other Csounders in Trondheim either. So I read the reference manual from front page to last page and didn't understand anything. Started over, and then it was a moment of gratification when I, after these 2-3 weeks or whatever long it took, managed to get my computer to say, doo. I was like, yes. So, but this was enabling the start, and this also gives me a reason to thank Alex and Joachim and the team working with the floss manuals for making it so much easier, and all of these other tools that we have. One of the early things I experimented with at this time was interactive dance, using sensor technology to capture movements from dancers. And in this setting, I combined Csound on a computer to do audio rendering with the Max to control the sensors and stuff. And just for context, I wanted to show a short excerpt of how that worked at the time. And we've probably missed the audio. Oh, right. Also, to talk about the versatility of the Csound language, I feel a lot of the time my students understand it to be connected with electroacoustic art music. And a lot of the music that we make with it is also electroacoustic art music, but yesterday we had some great examples also of more popular oriented music, and one thing I did in the early period was taking these sensors that I had developed for the dancers, putting them on my own body, even if I'm not a dancer, but using them as an instrument, and this as an example from that period.
If anything is sacred, the human body is sacred. If anything is sacred, the human body is sacred. I sing the body electric. I sing the body electric. I sing the body electric. I sing the body. Was it down to the dose to go up there?
So it was also at this time that Richard first invited me to Boston to do lectures at Berkeley, and that was an immense inspiration to be invited. And we all know how much Richard has done to us, for us. Seeing your car registration sign was also a moment of inspiration there. So with this early, the Maldonado, and this was in Csound 4, one of the more involved instruments that I started making also with the FLTK graphical opcodes was the Improsculpt, or the first version of Improsculpt. That another in our community, Dave Phillips, was nice enough to write about and make it a little bit more known. I remember Michael Goggins also saying when you guys produced Csound 5, he said, if we can run Improsculpt on it, it's probably complete. So much later, I took this Improsculpt idea further in my doctorate work, and thanks to the Csound API, I could now do some algorithmic composition routines in Python to support this expanding instrument, because not all operations are equally easy to do in Csound, so it's extremely nice that we have this opportunity to interface and connect to other technologies. This same instrument as in Improscope 4, which was used for live performance, has also been used in long-running Csound installations. And this is one of the more extreme environments that we've seen Csound running in. So this is a let's call it permanent sound installation. It started in 2006. It was supposed to run for 10 years, but it's been extended, so it will be run until 2026. And when setting up this, I had been given a 4-core server that should sit inside a university in Trondheim, and this is 100 kilometers north of Trondheim, so we connected remotely, sending sensor data over the network, sending audio back, and when setting this up, I had expected 4 times the performance. I had no experience with parallelization. So I contacted Victor. This was maybe a Wednesday afternoon, and the opening was on Friday. And I said, I have this 4-core computer. What can I do? It seems I can only use one of the cores. There's nothing happening else. I was like, yeah, we will need to have to look into this. Maybe this is a basis for an EU project or something. Okay, I need it by Friday. but we got some help, and parallelization in Csound has gone so much further after this. Just to show that hard work with Csound is not only about writing code, but making an installation in a park like this. There's also digging of ditches and laying of cables and such. This installation, for those who haven't heard it, it's running live online. So whatever is played on the sculpture here, you can also hear on a stream. And I wanted to just show a few seconds of what it sounds like now. That was this. And we have not had too much Csound in the Arctic, but there's some. I think maybe this is the northernmost Csound project that we have had, as far as I know. This image is from Ny-Ålesund at Svalbard. And the Norwegian Mapping Authority, they have an antenna there to measure distant quasars. And I was invited to do a piece for their headquarters and wanted to use this, the signals from these quasars to make music. And this is also a long-running installation. And I tell you this just to say that when we have installations running for tens and tens of years, it gives some credit to the tool that we're using, that it's running stable all the time. The other day I was asked to do a refurbishing of the flounder because the Windows service that it's running on, they go out of date, so they have to replace them. And And neither me or the technician that had helped me set it up remembered even the password to get into the old machine because we hadn't touched it since like for years. So, well, this VLBI music, it's the abbreviation VLBI stands for Very Long Baseline Interferometry, and this very long and convoluted words refer to a global network of radio antennas pointing to a distant quasar, measuring the distance due to the arrival time of the signal for different antennas. You can sort of triangulate, and then you measure to another quasar and triangulate that way. And we use this to find a stable reference so we can know where we are to be able to make any maps and satellite navigation and these kind of things. And this is also running live, so just a few seconds of what this sounds like now. I have no idea what it sounds like now. Let's hope it's good. Running at different speeds due to gravitational forces and rules of relativity. So some of the composition here is centered around having different clocks trying to adjust to each other, so they glide into soft synchronization, very slow soft synchronization. So with the Csound API and the ability to interface to other technology, there's also the concept of looking over to the other side. And the concept of bridges at all has been a poetic idea for me, something that I wanted to explore in several installations. And this is a public walking bridge in the city center of Trondheim, and the metal pavement is very resonant, and when people walk on this, it's like dong, 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 and you have someone coming with high heels, and it's pow, pow. So it's already really interesting there. So why add something? Well, for fun, maybe. So in this installation, I had contact mics on the paving and transducers, also exciting the bridge, and. Here, under that area, there's a whole room where you can find beggars spending the night, and there's a machine room for the bridge because it can can open, and we had the machine room for the installation. So there's Csound in the ground here. That was in 2012, and tonight you will hear my colleague Bernd in the concert, and he has been helping me with a lot of these projects. So tonight he will be in Oslo, I will be here, and we'll be playing together. This time he helped me with everything, making this installation happening. And more bridges. The Skarmsundet bridge in the middle of Norway connects two different municipalities, Inderøy and Mosvik, small communities, and the Norwegian state administration decided at some time that it was good for these small municipalities to merge to make it more effective. And they decided to go along with it, and this bridge was right in the middle of the border. So we decided to try to make some artistic element out of it. And I had always, when they called to ask about this, I was like, oh, yes, finally, yes. I've been looking at this bridge for so long time. It looks like a big harp, so thank you. So these strings, that I would call them stay cable wires, they are more like 300 meters long. The whole structure is 1,000 meters long. The base frequency, the fundamental of these strings, is 0.5 hertz. So, and if you hit it really hard with your hand, you cannot really. I mean, you can see the string is moving, but it's more the longitudinal vibrations that you can hear. So it sounds almost like a laser sword due to dispersion in the metal. So, and then a few seconds later, you get the impulse coming back. So a student of mine, Klaus Joachim Sonstad, he helped me build an accelerometer and to convert these vibrations. And we took it into Csound, and with spectral manipulations in Csound, transposed it up so that we could actually work with this as sound. There's a whole piece made on this, but I'll play a short excerpt. You can hear the vibrations of the wires in the beginning, and also the architectural shape of the bridge shapes some of the phrases in this piece. Then something rather different, but also related to connecting different domains. Together with my colleague Axel Tiedemann, did this more conversational robot with Csound a few years back, where artificial intelligence techniques are used to recognize sounds that the robot will hear, and then it learns how to talk. A lot of you saw this in the Csound conference in St. Petersburg, so I won't spend too much time delving on that right now. But me and Axel is working on a new instrument that you might find interesting to sort of hear about. And this instrument will take any kind of sensor input. It's not really important what inputs it gets, but we will use the AI then to try to match the mapping of these sensor inputs to synthesis parameters, and then the sound coming out from Csound will then be analyzed, or we analyze it in Csound, but output some feature vectors of pitch and different characteristics of the sound. And the AI is good, an AI method is good for matching one set of variables to another by regression. So the idea is to ask the AI to map the input parameters so that the output sound will have some of the same gestural qualities as the input. So if you do this, the output sound will have some sort of pow kind of character. And we don't know in what way it will have that character. So that's for me, the interesting part of that. Csound is also really good for teaching, as many of you know. And one thing that it enabled us to do in this project, which was also a collaboration with Victor back in 2011, I think, was the air training based digital signal processing course, which is online and free for anyone to use. And all of the routines, signal processing routines that we teach in this course are just single include files and can be assembled programmatically. So then it's pretty straightforward to have a Python script assembling new Csound instruments, rendering a new sound file, and asking the student what happened here. Identify what kind of processing was done. And also using Cabbage in teaching, I realized now a few weeks back when teaching our new master students, which are a very interdisciplinary crowd of people. Some of them have no experience with music programming or composition, but we have philosophers or people from the social sciences and engineers from other fields also coming in. And then being able to give them the signal processing routines as Cabbage plugins with a button to turn and become familiar with how it sounds and how it feels. And then say, when you're ready, the code is there. It's just 2 steps away and you can start modifying it. And as I said to them as well, probably breaking it when you start modifying it. But then, I mean, it's there. You can always go back and forth. Yeah, the Hadron particle synthesizer is one such instrument that was built also in JUICE, pretty similar to what we do with the Cabbage. And this was built upon the particle opcode that I developed a few years earlier. And yeah, short excerpt of the very first piece that I wrote with the Hadron here. So this was also a collaboration project where helped me build the ST wrapper, and Brandtsegg did the Maxwell Live wrapping. And the reason for mentioning this instrument as a celebration to Csound, I think, is also in terms of Csound as a stable platform. Let's just look at some. I mean, I'm most a fan of qualitative assessment But for this single instance, let's just look at some numbers. So since 2010, there's been our website reported that we had 250 downloads of this. It seems like a fantasy number, and I thought there must be something wrong. But by the end of last year, the website broke down. So we had to make a new website and reset the counters. And from January to now, we have actually 1,900 downloads. And this is 10 years after the piece was released, and we've done nothing to promote it. So this is good. Has it been any business for this hundred of thousands of downloads? Not so much. I think Alessandro would be a good one to ask to help make this. But that's not the point at this case. Has there been any need for technical support from all of these thousands of users? Not so much, actually. Over these 250 downloads over 10 years, we have had 350 support requests. And most of them are just saying, thanks for this thing. How do I run the installer? There's some small snags about getting the paths for the plugins. And then also a few people saying, oh, I installed this thing, so what does it do? So, of course, there might not be 250,000 musician users actually using it, but still, it does tell volumes about Csound as the robust platform running stable with a massive amount of users and very few problems. And that's thanks to the solid way it was built by you guys. So, in terms of exploring new methods for signal processing, convolution had been for several years something that I had wanted to explore and thinking, well, when we play together on stage, why can't we? Convolution is playing one sound through another. Why can't we just play through the sound of each other with two acoustic instruments? And Victor and Sigurd Saue worked on this project together with me. This is my colleague Trond Engem's concept of convolution, of playing one thing through another. And Sigurd and Victor helped me explore different concepts of convolution, different ways of doing it. And one idea that Sigurd had, because you cannot replace the impulse response in convolution without getting artifacts. You sort of have to stop the process, reload, and then start all over again. But Sigurd said, what if we just start at the beginning of the filter? Replace the filter coefficients one by one at the same rate as audio is coming in, and then you can just replace it. I must admit, I said to him, no, it's not going to work. But due to the opcode structure in Csound, we had the ftconv2 opcode, which was doing exactly what we needed except the replacement of the filter. So we could just use that as the basis and replace small parts there. So most of the work was already done by the Csound community. So that also tells that for new inventions, a lot of the framework for experimentation is already there, and that makes it possible to enable this kind of work. Okay, this was part of a larger research project called Cross-Adaptive Audio Processing, and for those who don't work with that on a daily basis, I'll quickly just say that this relates to extracting features from one sound, like pitch, spectral content and such, and use those as control vectors to control the processing parameters of another sound, and having that as a way of intervening into the musical communication between two live performers. For this, we also used Cabbage to build a big analyzer software. So this is the Cabbage front end, and behind this I imported techniques from the music information retrieval literature on different ways of analyzing sound to extract some perceptual features. And again, Victor helped in expanding these the available techniques in Csound to also include capstral analysis and these mel-frequency capstral coefficients that allowed us to do this precedness, like how when you perform on an instrument and you introduce more energy and effort, the sound becomes more rich in performance and more pressed. So this was a way of measuring this. Also connected to this was developments of the open sound control methods in Csound, enabling us to do like a learn function, so that when this modulator bus that you can see in the center of the picture here asks the Reaper, for example, the DAW, about what is the address of this control, you will actually get the address back from the DAW. But we didn't have a way to read raw open sound control messages, so the OSC raw opcode was a way to get around this, and Victor helped us build it. Then we can route the collected analysis signals from several instruments and massage them a little bit, and then control anything in the DAW. And one thing that I commonly use, the few things I use that is not Csound, is the Valhalla reverbs, and they have a lineage coming back from Csound. So must have been when was the Sean Costello reverb implemented? Someone remember? 99, yes. So we still have his reverb experiments from there. It's also as an opcode, but we have the whole instrument code, so we can inspect the early lineage of those reverbs. And of course, it's infinitely more refined and expanded over the years. But it also pedagogically, this gives a way to look into some commercial project that is really polished and nice, and we can ourselves studies and tell our students how to learn more about this. So with the cross-adaptive processing, just a short excerpt also of live playing using these techniques together with Maja Ratche and Kim Henry Utveit on percussion. Okay, if you want to hear more of this, it's released on an album. I have some of them with me as well. And this project was a collaboration with a lot of universities and institutions, and also freelancers. And Rory was in there, Victor was in there, and Sigurd was in there, and Bernd also. Just a few words about where I'm coming from. I'm at the Norwegian University of Technology and Science in Trondheim, and we have a bachelor program where Csound is integrated into the composition and thinking. Two master programs, one in artistical research and one more academic and polytechnically inclined as a collaboration with the University of Oslo, and also a program of PhDs in artistic research. So I invite all of you to think about applying or asking your students to apply. And this is a fully funded position for 3 years. There are calls once or twice a year now when it's being established. And the artistic research PhD is much more focused on exploration and practical implementation and experimentation with some artistic element, also involving oftentimes technology. So, and the creative music technology master is the natural lead up to that. So please invite and apply. As we can see in our community, the gender balance is not always perfect. So one of my colleagues in Trondheim, Anna Shambu, has led the work on women in music tech Norway. And this is something I would also invite you to tell your colleagues about and to help spread and maybe start instances of in other places. So recently there was an Wonomute Oslo that had started, and there's a lot of talks and presentations from women artists working with technology. Let's see, where are they all? And we do interviews with all the presenters when they have done a workshop. There's an interview about how they came into this line of work and the backgrounds and everything. So that's Wonomute. And soon there will be a web audio conference in December in Trondheim, where there's also some Csound related web audio work I know. And lastly, I will invite you to submit to the Live Interfaces conference that will be in March in Trondheim, back to back with the Metamorph Biennale for electronic art. And for Live Interfaces, we have a call. The theme this year is on artificial intelligence and automated emotional intelligence, if that's a valid concept. But the Live Interfaces conference is about all sorts of interfaces, all sorts of bridging over. So in this respect, even language is an interface. And last year there was a keynote about Indian dance and how the structure and the knowledge of both performer and audience acts as an interface for underlying themes also there. So that's it. Well, with all the projects I have presented, I hope it's really clear that it's not really I who made this. We made this together. And for this, I am immensely thankful to the Csound community and the help from everything, and the Csound list, not the least. We've been there have been efforts to move these discussions over to more modern fora. I'm really slow at going there, but the Csound list has been like the main school for me. So for this and for everything from the Csound community, I thank you very much.